Hello students, welcome you all. We were discussing about structure of an atom and today's our topic is to discuss about limitations of Bohr model. So before going to the topic, let us revise what we covered till date. We have covered electromagnetic spectrum, emission and absorption spectrum, line and continuous spectrum, and we had discussed about Bohr's postulate also. Dalton atomic model was the first model which we already discussed. Discovery of electron, how proton were discovered, neutron, nucleus was discovered by Rutherford model of an atom. Then we discussed about Bohr model of an atom. Bohr postulates were like orbit, stationary, orbit is quantized, energy of the orbit is quantized, higher is the orbital, higher is the energy. That all were the Bohr's postulates. And then next today's topic is to discuss about a dual nature of matter and uncertainty principle. So before going into the today's topic, I want to cover one more topic which was related to previous one, related to Bohr's postulates, that is Bohr's radius. Bohr's radius mean radius of an orbit. That formula is there for calculating the radius of an orbit according to Bohr, that r is equal to 0.529 into n square by z angstrom. This is the formula. Rn is equal to 0.529 into n square by z square angstrom. N square, here n is number of orbit, z is atomic number, angstrom is unit only. So this formula we will be using to solve the numerical, where they will ask about the radius, calculate the radius, then you will use this formula. So let us do one numerical also based upon this formula. Calculate the energy associated with the first orbit of helium ion. What is the radius of this orbit? Means here they ask two questions, one related to energy and one related to radius. So we will apply two formulas here. As we already studied about energy, that formula was En is equal to minus 2.18 into 10 raised to the power minus 18 z square by n square joule per atom. This formula already we have discussed earlier. Z square here is a atomic number, n was a orbit number. So here fill the value, n is equal to 1 given, z is 2 for helium. So after putting the values, and you will be getting answer for energy E1, that is E energy of first orbit. That answer will come minus 8.72 into 10 to the power minus 18 joule. So as second question they asked for the radius, and radius formula now we know. Rn is equal to 0.0529 z square by n square. Now here formula is 0.0529, not 0.529. We have studied about 0.529, but that was in angstrom. This formula is in nanometer. So due to that conversion only, this formula becomes 0.0529 z square by n square. Z square here once again it is 2 here because it is helium ion. N is again 1 because it was first orbit given. So after filling this value, our radius will come 0.2116 nanometer is the answer. Now let us come to today's topic, that is limitations of Bohr model of an atom. So very first limitation, or you can say drawback, why this Bohr model was failed, due to these reasons it was failed. The first limitation is Bohr model was failed to explain the finer details of the hydrogen spectrum. I hope you remember the hydrogen spectrum gave rise to Lemon series, Balmer series, Paschen, Brackett and P fund. Now that in between that spectral lines, there were found few finer lines were also there in that Lemon series and Balmer series. Also certain finer lines were also observed. This Bohr model was unable to explain that why that finer lines were appeared in Lemon or Balmer or Paschen series. So this was not explained by Bohr model, so it was a limitation. Second limitation is Bohr model was also not able to explain spectrum of atoms containing more than one electron. Bohr model was only explaining the hydrogen atom which was containing only one electron, but this model was failed to explain like lithium which were having 3 electrons, beryllium. So such kind of atoms were not able to explain by Bohr model. So next limitation, Bohr model was unable to explain about Zeeman effect. Now you would ask, what is Zeeman effect? Zeeman effect is the splitting of the spectral line in the presence of magnetic field. If you apply the magnetic field, the spectral lines will further split. Why that splitting was there, the Bohr model was unable to explain why that spectral lines is split into the other lines in the presence of magnetic field. And similarly, Bohr model was also not able to explain the Stark effect. Stark effect is what? It is splitting of the spectral line in the presence of electric field. Means spectral line will split into the parts in the presence of electric field. Why it happens, that Bohr model was not able to explain. That is called Stark effect. Next is, let us one more limitation is there. Bohr model was also not able to explain Heisenberg uncertainty principle. That I will tell you what was this principle. And one more limitation, Bohr model also suggested that electron is supposed to be particle, but nowadays it is being considered that electron can have a wave nature also, because Bohr said that electrons are in a particle form, but nowadays it is found that electrons are behaving in wave nature also. These two more limitations were there for Bohr model of an atom. So for more details you can refer this YouTube link is there given, you can refer and see the video. As I said that electron is having two type of nature. Electron is having particle nature as well as wave nature also. Scintillation produced by electron on zinc sulfide screen is accountable for the particle nature. And Davison and Germer were two scientists who has done one experiment and proved that electron possess wave nature also. That experiment detail in not our syllabus. So both these particle nature and wave nature was told by de Broglie. De Broglie, one scientist, he has given his hypothesis. He said that electron is having both particle nature as well as wave nature. So we will discuss that also. What is de Broglie hypothesis? So let us come to the topic which I told you, Heisenberg uncertainty principle. What was it? Who Bohr model was unable to explain this principle. So first of all, definition of this principle is what? Very important definition, can also be asked in the exam. Heisenberg uncertainty principle states that it is impossible to determine simultaneously exact position and exact momentum of a fast moving electron. Very simple. uh, Electron revolve around the nucleus in an orbit. If you want to find the velocity of that electron, then at the same time you cannot measure the momentum of that electron. That is only the Heisenberg uncertainty principle. Means if you want to find velocity, then momentum cannot be found. If you want to find out momentum at the same time you cannot find the position of the fast moving electron. So this is only the Heisenberg uncertainty principle. Mathematically it is equal to delta x into delta p is equal to h upon 4 pi. Delta x here is uncertainty in the position and delta p is uncertainty in the momentum. H is the Planck's constant, 4 is constant, pi is also constant, that value you know. So as mathematically delta x dot delta m into v, as you all know, p momentum is always equal to mv. Thereby on the place of p you can write mv, that is equal to h upon 4 pi. So therefore delta x, m is constant, that is the value you know for an electron, mass of an electron, that m will come out. Delta v is equal to h upon 4 pi. If you keep delta v here and m will go down, so therefore it will become delta x into delta v is equal to h upon 4 pi m. So here everything you know. Delta x is uncertainty in the position and delta v is uncertainty in the velocity, and p means uh, mv is equal to p, that only. So I hope it is clear. So you keep this formula in your mind, because question numerical will be asked on the based upon Heisenberg uncertainty principle. Let us see one numerical also based upon it. For more detail about it you can refer this link on YouTube, you can check it out. And for numerical, let us discuss one numerical based upon this principle. See the statement: a microscope using a suitable photons is employed to locate the electron in an atom within a distance of 0.1 angstrom. What is the uncertainty involved in measurement of its velocity? Means we have to calculate delta v, uncertainty in the velocity we have to calculate, and definitely uncertainty in the position has been given to us, that is 0.1 angstrom. Angstrom unit you have to convert into meter, because SI unit meter, so that 0.1 angstrom multiplied by 10 raised to power minus 10 meter, so thereby unit SI unit. So apply the relationship formula, you apply Heisenberg uncertainty principle, that is delta x into delta p is equal to h upon 4 pi. This formula we know. So as on the place of delta P, you can write down M delta V. We can write down this one M delta V on the place of P. Thereby formula will become delta X M delta V is equal to H upon 4 pi. From there you can calculate delta V, delta X and delta X and M will go down. So H upon 4 pi into delta X into M. M is the mass of electron. Delta X has been given to us, pi value we know, 4 we know already. So we will put all these values. H, a Planck's constant, that is 6.626 into 10 to the 34 joule second, divided by 4 into 3.14, that is pi value. 0.1 was given to us, angstrom, and we multiply into 10 to the 10 the meter, then multiply by 9.1 into 10 to the 31 kg, that was mass of electron. So we will get the answer 5.79 into 10 to the power 6 meter per second is the uncertainty in the velocity. This way question will come based upon Heisenberg uncertainty principle. So one more numerical you can practice, and here is that which way I said, de Broglie, who has said that electron is having two type of nature, particle as well as wave natures. How it came? So this relationship is very important. De Broglie hypothesis or de Broglie equation derivation can also be asked. More detail you can check, refer your book to write each and everything. So here, as we know, Einstein has given one mass energy relationship, that is E is equal to mc square. Every child know about it. And Planck's also given one relation, that is we have studied in the beginning, E is equal to h nu. These both things, E is equal to h nu. Nu value, you know, one more relation was there, C is equal to nu lambda. From there nu value is equal to C upon lambda. So on the place of nu you have written E is equal to h C upon lambda. On the place of nu you have substituted the value C by lambda. So now equation number 1 and equation number 2 you equate both the side. E energy is same, that means right hand side will also be equal to each other. Thereby mc square is equal to h C upon lambda. C will cancel out to both the side, you see mc square here hc. So cc will cancel out. mc is equal to h upon lambda. From there h upon mc is equal to lambda. Lambda you can calculate h upon mc. M is the mass of electron and c is the fast moving electron velocity, that is velocity of light, you can say. So if it is a material particle, then velocity of light c will change into v. So on the place of c you can write down v, because material particle you cannot have velocity of light. So on the place of velocity of light you will change it with the v. So lambda will become equal to h upon mv. So this is only the relation de Broglie hypothesis or de Broglie equation, that is lambda is equal to h upon mv. Or else also it is written in the book, lambda is equal to h upon h upon p. mv is equal to p, mean momentum. So this related to this numerical also will do in the next class. Till the time you can refer your book for this derivation, which is very important. This link also you can refer for de Broglie on YouTube. Thank you very much.